Okay, in this section, it's section 7.1, we're going to be talking about inverse functions. Now, it's important to keep in mind that inverse and reciprocal are two different things. So, for instance, I'm going to write this up here, it's pretty important. Inverse sine of x is not the same as cosecant x. Okay, so when I say inverse, what I'm actually asking for is, what's the angle? So let me just give you a real quick idea out here. If I say sine theta equals a half, you can think about your 30, 60, 90s, and we're going to answer all of these in radians, but for now, just so you get an idea, your answer to this one would be theta must be 30 degrees. Okay, so when I talk about inverse, when I say at what angle or angles does sine equal a half, your answer is going to be the angle measure, 30 degrees. And like I said, I'm going to ask for radians in this, but I wanted to just give you a quick example. Okay, now if we look down here, we're going to go over all three functions, the basics, inverse sine, inverse cosine, inverse tangent. And the way we're going to approach this is through a graphing approach. So if I look at a sine graph, okay, so I'm going to do a real rough sketch down here. We've done a bunch of these, so we should be pretty okay at this point. Right, rough sketch of sine. Draw it in. Here's what it would look like. All right, and then if we want to start answering inverse questions, kind of the tough thing we need to think about here is it has to be what we call 1-to-1 in order to calculate an inverse. Now, if you don't remember what 1-to-1 means, it means it has to pass a vertical and horizontal line test. In other words, every x gets one y, every y gets one x. So if I look at this blue sine x curve, you can see it's definitely not 1-to-1. It does not pass the vertical line test. Actually, excuse me, it does pass the vertical, but not the horizontal. Now, that doesn't mean that we can't calculate inverses. It simply means we need to restrict the domain a bit so that it is 1-to-1. And the part that we're going to look at for sine, in order for it to be 1-to-1, is going to be the part from pi over 2 to negative pi over 2. Let me show you why. So if I continue my sine graph and I only look at this kind of yellow swoop in here, from negative pi over 2 to pi over 2, that yellow part is 1-to-1. So I have to make sure I only look between negative pi over 2 and pi over 2 for the sine curve. Okay, so what I've just graphed there in yellow is still sine. So what I want to do out to the side here, under the graph portion, is graph what the inverse sine would look like. And now we have to remember to graph inverse functions, we're going to switch the x and y's. So in red here, this is going to be y equals inverse sine x. Okay, so here's what we're going to graph. Now, the yellow part on the sine curve, on the x-axis, that's going to become our y-axis. Okay, so the pi's are now going to be on the y-axis. And then it makes sense that the 1 and the negative 1 will then be on the x-axis. Okay, so we're switching the x and y's, switching domain and range, and then I'm going to get this red curve in here, so it's inverse sine. Now, the good news is we're not going to have to do a whole lot of graphing in here, but it is really important to look at this graph in order to determine what values I can answer, meaning when I do inverse sine, the only answers I can give are going to be between negative pi over 2 and pi over 2. So we're going to do a bunch of examples, but you should never give me an answer like pi for inverse sine. Pi is way too big. It's got to fall between pi over 2 and negative pi over 2. Okay, so let's just talk about this. Domain and range. Now, domain of the inverse function now, not sine. Domain is going to be inclusive, negative 1-to-1. So on my red graph, the possible x values are negative 1 to positive 1. The range, the y values on the red graph, negative pi over 2 to pi over 2. Okay? So it's pretty important. Now, for the defining equations, here's what I want you to say, something like this. You don't have to put it in perfect sentence form here. But when you're answering an inverse sine equation, you are saying the inverse sine is the angle. Okay, so your answer is an angle between negative pi over 2 and pi over 2. So your answer should be an angle and only between those two values. Okay, basic properties of inverse functions. In other words, composing trig and inverse functions together. Here's one example. If I asked you the sine of the inverse sine of 1/2, and I asked you what that equaled, here's what your thought process is going to start becoming. It's going to be kind of tough, but we're going to do a bunch of problems like this. If I ask you, what angle gives me an inverse sine of 1/2? In your head, maybe you think about it immediately, maybe you don't. But the sine of a 30, 60, 90 is the one that's going to give me 1/2. Okay, so opposite hypotenuse. Now, what angle is that? You might be thinking 30 degrees, that's fine. But again, I want you to really, really start thinking in radians. So what this is going to become then is sin, sine, this sine. And then if I say the inverse sine of 1/2, what is it? We're going to say it's pi over 6. Okay. Now, what's the sine of pi over 6? What's the sine of 30? Well, we're right back to where we started, 1/2. So, when you compose trig functions with inverse trig, sine of the inverse sine of 1/2. There's some things that can make this kind of difficult, but at its easiest level, your answer is just 1/2. So if I put it in symbols only, think about this. Sine of the inverse sine of x is always going to equal x. Again, there's some things we'll talk about later that make it a little more difficult than that, but that's one of the main properties. Okay? Another really big property, if I put the inverse on the outside, inverse sine of the sine of x also equals x. So an inverse sine function and a sine function kind of undo each other. All right, we'll talk a lot more about that. Now we're going to go through that whole thought process again for cosine x. Okay, so we're going to go through it all. You don't have to prove this every single time, but I want to talk it through again. All right, take a look at cosine. So cosine x, if we were to graph it, all right, would look like this. So here's my little 2 pi out here, my pi here. Cosine kind of takes this shape, right? Okay, and then again, if I'm trying to answer the question, is it 1-to-1? It definitely is not. Okay, so it doesn't pass the horizontal line test at certain points. So what I'm going to do again, I'm going to restrict the domain. This time, I'm going to restrict the domain from 0 to pi, because if you look at this little yellow part, that's definitely 1-to-1. Okay, and if it's 1-to-1, then I can calculate an inverse. So if I'm looking at the cosine curve, once again, and move it into an inverse cosine, not secant, but inverse cosine, the y values become the x values. Okay, and if I'm looking at this little yellow swoop over here, I'm looking from 0 to pi only. So when I'm graphing it, I'm only going to look from 0 to pi. Okay, so then if I kind of plot my points by reversing my x and y coordinates, this yellow graph here is inverse cosine x. Okay, so now let's fill in domain and range. Take a look at domain for inverse cosine. Should be negative 1-to-1. Okay, the range of inverse cosine is different from inverse sine. The range is 0 to pi this time. So when you give me answers for inverse cosine, you can only give me angles between 0 and pi. You'll never answer with 2 pi or any angles like that for inverse cosine. Okay, define the equation. So here's another one. Inverse cosine x is the angle always between 0 and pi, so that it's 1-to-1, okay, whose cosine is x. All right. Okay, for the part below, some of the properties, same ones as sine. And again, we're going to make these a little more difficult later, but for now, cosine and inverse cosine undo each other, so the answer would just be x. Same if we go on the reverse. Inverse cosine of the cosine, undo, answer is just x. All right, last function, inverse tan. Okay, let's approach it the same way. Here's our basic tan graph. All right, we go negative pi over 2 to pi over 2. Okay, take a look at it. Get asymptotes here. Okay, 0 here. And then here's kind of what tangent looks like. Now, if you look at tangent, turns out it actually is 1 to 1. So when I graph the inverse tan and I switch the x and y axis, this one remains 1 to 1. So when I'm doing this, it's actually going to have horizontal asymptotes instead, because I'm switching. So it's actually going this way. Okay. And when I turn my graph sideways, because I'm turning all the x and y values, here's what happens with inverse tan. Okay, so it kind of goes on forever. So the domain of inverse tan then is negative infinity to infinity. I can have all kinds of big numbers for domain. Now the answers, the range, they're still going to be negative pi over 2 to pi over 2, except this time we're not going to include those because they're actually asymptotes. Okay, so kind of specific on that domain and range. All right, defining equations, same idea. Inverse tan is the angle, this time between negative pi over 2 and pi over 2. Okay, pretty important. All right, same properties. Tan and inverse tan undo each other in its simplest form. We'll talk about it later. Inverse tan and tan also undo each other. All right, we'll finish up tomorrow. We'll do some example questions.